So now the pool itself is, this is a cross section of the pool. So you can think of the pool as something like this. This is a view it from a certain angle. You see this, right? Now, so if we can find the area of the cross section and multiply by the width, that would be 30, you will be able to get the volume. However, we're only interested in this part, the triangular part of the pool, because the reason is h is bounded between 0 and 5. You think about this, is 6.5 meters. It's 1.5. So, well, we're trying to say that, okay, this is actually really just between 0 and 5, and so that just involved the triangle here. This is a response to part A. The volume would be the area of a cross section times the width. And in this case, area would be, well, the water. Of course, we're talking about water. The x and h, and this is a triangle. It will be half times the base, well, it could be x times h and x, and times 30, and so the outcome is 15 hx or 15xh. So for us to respond to part B here, we just focus on the triangle. If we draw this, let's illustrate this here, the triangle, okay, and the volume of the water somewhere here, could be up to 5 meters in depth, but here is actually represented by the height or depth of the water is h, this is x, but this triangle, the larger triangle, this is 5, whereas here is 70 from one end to the other. Using similar triangle, we should be able to see that the x over h, right, is really 70 over 5. They have the same ratio. So you will end up having x equal to 70 over 5 h. And this is really just 14h. So this is a relationship between x and h, the height or depth of the water, and also this length, from one end to one end of the water. And because of this, using this idea and this relationship, so V is 15 hx. But then again, because x is equal to 14h, we end up getting 210 h squared, which is really what we asked to show. And then the dV dt, we just derive this. This would be 420 h. But of course, h is in terms of time too. So you get dh dt, and that this is dV dt. So let me write this down. We have shown that dV dt is 420 h dh dt. What's the use of this relationship? Let's check and see. The pool is being filled with water at 130 cubic, so that this will be dV dt. Here, this part, this is dV dt really. And then the depth at the end is 2 meters. What is then the rate of change of depth of water, which is really h. So then we are being asked to find dH dt. Pretty straightforward. So task is more or less substitutions. 130 equal to 420, and depth of the depth at the deep end is 2 and being asked to find dH dt, and we should get dH dt be equivalent to 13 or 84 meter per minute.